Welcome to CH225 course on Statistical Data Analysis for Chemists. I am your instructor, Anil Kumar. These are my contact details. This is video 11 in this series. In this video we will learn about box plots. We have already discussed techniques for visually representing data, such as histograms, frequency polygons and stem and leaf plots. In this section, we present another important graph called a box plot. Box plots are useful for identifying outliers. These are also very helpful in comparing distributions. We will explain box plots with the help of data from an in-class experiment. Students were presented with a page containing 30 colored rectangles. Their task was to name the colors as quickly as possible. Their response times, in seconds, were recorded. We'll compare the scores for the 16 men and 31 women who participated in the experiment by making separate box plots for each gender. Such a display is said to involve parallel box plots. Here is the data obtained for the 31 women participants. There are several steps in constructing a box plot. The first relies on the 25th, 50th, and 75th percentiles in the distribution of scores. This figure shows how these three statistics are used. For each gender, we draw a box, extending from the 25th percentile to the 75th percentile. The 50th percentile is drawn inside the box. Therefore, the bottom of each box is the 25th percentile, the top is the 75th percentile, and the line in the middle is the 50th percentile. We now calculate other parameters, as shown in this table. The 75th percentile is called the upper hinge, whereas the 25th percentile is called the lower hinge. The difference between the two is called the H-spread. A step is nothing but the 1.5 times the H-spread. The other parameters are easy to understand from this table. All the values shown in this table correspond to the data from the women participant table, as given earlier. Please check and confirm each parameter. Once we have calculated these parameters, we can proceed further to complete the box plot. We put whiskers above and below each box to give additional information about the spread of the data. Whiskers are vertical lines that end in a horizontal stroke. Whiskers are drawn from the upper and lower hinges to the upper and lower adjacent values, 24 and 14 for the women's data. Although we don't draw whiskers all the way to outside or far out values, we still wish to represent them in our box plots. This is achieved by adding additional marks beyond the whiskers. Specifically, outside values are indicated by small o's, and far out values are indicated by asterisks. In our data, there are no far out values and just one outside value. This outside value of 29 is for the women, and is shown here. There is one more mark to include in box plots, although sometimes it is omitted. We indicate the average score for a group by inserting a plus sign. The result of adding average to our box plots is shown here. This completes our box plots. Box plots provide a revealing summary of the data. Remember, the box represents half the score, as it is at 25th and 75th percentiles. We see that half the women's times are between 17 and 20 seconds, whereas half the men's times are between 19 and 25.5. We also see that women generally name the colors faster, than the men did, although one woman was slower than almost all of the men. Here is a box plot for the women data, with all the labels from the earlier table. Here are the box plots for the data from video 10 involving time taken to move the cursor to a smaller and larger rectangular space on the screen. You are all required to look into the data and draw box plots of your own, and to confirm the final plots. Box plots provide basic information about a distribution. For example, a distribution with a positive skew would have a longer whisker in the positive direction than in the negative direction. Box plots are good at portraying extreme values. Box plots are especially good at showing differences between distributions. However, many of the details of a distribution are not revealed in a box plot, and to examine these details, one should create a histogram and/or a stem and leaf display.